Now we come to the last topic of Webtalk 10, namely LCA at 2 time points. So LCA at 2 time points looks like LTA and has a lot of similarities with it. And we're going to look at the relationship between the two. So we have 2 time points, 6 indicators at each of the 2 time points. But the 2 time points can have different latent class constructs, dealing with totally different things, and different types of latent class indicators, and different numbers of them too, although they're the same in the picture, and we can have different number of latent classes at the 2 time points. In this case, since it's different types of variables and different latent class constructs, it does not make sense to include a random intercept at the top. So RI LTA wouldn't be relevant for this situation. The latent trait addition would not be relevant. We're interested still, like in LTA, of predicting C2 classes from C1 classes. And we have the multi-step desire to not have time point 2 indicators influence the time point 1 class formation, and vice versa. So you can think of this whole thing here, the latent class variable out here, latent class model out here, as a distal outcome part of the model, where the first step relates to the first time point measurements. We're going to talk about the BCH multi-step approach inspired by LTA, where the first step is going to have no measurement invariance, because we are talking about different types of latent class constructs and different types of latent class indicators. Measurement invariance would not make sense. But like LTA, the first step is going to have no C2 on C1. In the last step then, what is the last step? Well, we're going to see that the last step has no observed variables. It's interesting. And includes C2 on C1, nevertheless. So why no observed variables? Why not U7 through U12? Well, let's see. Slide 83 shows the first step of BCH for this LCA at 2 time points. So it's the familiar data set up here. And now part of this approach is for the use variable list to include all 12 indicators. So indicators from both time 1 and time 2. So we have 2 latent class variables. And in the overall part of the model, we do not have C2 on C1, which makes it possible to create BCH weights that are estimated via independent LCAs for the 2 time points. We see here on the right that we have no measurement invariance imposed. So no measurement invariance together with no C2 on C1 creates the BCH weights in line with the first step of LTA. So all 12 variables are estimated or handled in the first step. Slide 84 then. The last step of BCH, we have the BCH data set, and we have a names list, the indicators, all 12 of them, and the 9 weight variables, 3 times 3. Now we're going to say use variables equals the weights. If we didn't have any use variable list at all, the model analysis, the analysis of the model would include all of these variables, which we don't want. But if you say use variables equals W1 through W9, then those get dropped off and are not used in the model explicitly, but only are used for the training statement down here. So it's a little trick. So none of the observed variables play into the second step here. Instead, all of the information is summarized by the training variables, the 9 training variables. And since it's the second step, we have start equals 0, and then we do C2 on C1 here to get the information of how C1 influences C2 for LCA at 2 time points. And that's the end of Webtalk 10. We have an appendix here where we show how to do the Monte Carlo generation of the LTA dataset, LTA distal N2K. And I'm not going to go through that. It's created in a similar way with missing data on X's and on Y's as we did for the Webtalk 8 data generation. And it continues here, and then we have some references at the end. Thanks for listening.